Okay, thank you everyone, first of all, for joining this. My name is Prashnna Ghimire. I'm a PhD student at University of Nebraska Lincoln, USA. And my talking about brief background, I'm doing PhD in construction engineering and management. Today, my colleague Hafiz and I will be presenting on robotics applicability for routine operators tasks in power plant facility. So let's start the presentation now. First of all, talking about a little bit background of the team members on this study. Me, myself, Prashnna, Ghimire, and Hafiz. He is also a PhD student. And Matt is postdoc. Kyungki is assistant professor, and Phil is also assistant professor from Durham School of Architectural Engineering and Construction at University of Nebraska Lincoln. A little bit about background. Robotics application in facility management has been increasing to address different safety concerns, and the environment of facility management, in particularly power plant facility, is more dynamic and less predictable, which is not similar to other industrial robotic environment in current practice. So to avoid the human exposure to the harmful environment, such as very commonly high radiation, temperature, and humidity, we started this study. If we can find a path, a new avenue to solve this problem, and the automation that can help in early detection, and so that we can solve the problem of risks of adverse condition of the routine operator tasks and inspection in the robotic in the nuclear facility management system. So the automation system can drive down the risks and human-based error, and the accident based on that, and help to increase overall performance like cost, and even the currently we can see the labor shortage problem in the industry. That can also be one benefit of the automation in this realm. So particularly in power plant facility management, we can see the different options, either the tasks that can be executed by either human, machine, or combination of both. So the one area we studied is the routine operator tasks, which is more tedious than other tasks, daily activities by human. And we found out that we can develop a robot that can help routine operator tasks in conjunction with the human. So robot is not working independently, but with the human, it can be a better output. So the key rationale of this study and utilization of robot for routine operator tasks is to enhance the operation that are more tedious, routinely lengthy, and requires high accuracy and consistency, and also involves high risks to the radiations and different adverse conditions in that environment. Some examples are steam generator examination, tube leak plugging, dripping, gauge readings, turning the bulbs, and that can be some more. So, but the current practices in the industry is a robot is working particularly for a specific task. So our aim for this study was to automate a routine operator tasks of monitoring power plant equipment using a robot. And under that, to be very specific, the objectives are to create a robot-based system for monitoring of power plant equipment, to autonomously navigate a robot to power plant and take gauge reading, and estimate the gauge reading of the power plant equipment, and to test the performance of proposed system in a simulated environment. And a little bit about the background. We developed the background with the discussion with the industry practitioner working in the nuclear power plant facility, and ideal typical area plan of the power plant facility involves nuclear reactor, auxiliary area, fuel area, turbine generators, control area. And we developed our robot to work on particularly turbine generator area of a nuclear facility that contains that involves different components like turbine generators, condensers, condensate pump, feed water pump, etc., and that has valves and gases, multiple valves and gases in the system. So currently the practice is a human like routine operator works on the daily basis and reports to the license operator, and our aim is to robot to work on this environment and work with a license operator so that we can avoid the risks and we can make the process more efficient, more accurate, and more safe. So now onward, I want to pass it over to my colleague Hafiz for the further presentation.
All right, thank you, Prashnna, and thank you everyone for listening in. Like my colleague said earlier, my name is Hafiz, and so like he said, we spoke to some professionals in the power plant system. We had an extensive discussion with them before going on the project, and we discovered that they spend a lot of time routine operator tasks. Like they have people that goes around to check like gauge reading, leaking pipes, and basic tasks that we believe are repetitive and can be carried out by a robot. So in order to experiment on these ideas on how a robot could perform these tasks, we created a scenario where we have a robot. We created a scenario like you showed earlier on, where a robot goes in, it navigates autonomously to one of the equipments as shown in the slide here, and it looks at the gauge reading as a first step. It looks at the reading of the gauge, and it's been able to autonomously say what the gauge reading is, rather than have people go there. So we can just have a robot navigate to that spot and do that. So in terms of the pipeline or how the work was carried out, majorly the idea is that for this first phase of the work, we deploy a robot. As you can see from this, we deploy a robot by triggering some commands. The robot navigates autonomously to the preset locations. For this study, we had coded some spots at the front of the equipment. So it goes in and it rotates facing the equipment. Then it takes a picture of the equipment, and from there, it crop out the area where you have the gauge. Then we do some image processing on that image based on the dial gauge. So, and the reading of the valve itself, based on the dial gauge and the reading of the valve itself, then it estimates the pressure reading at that point in time. So this is like the scenario for the case study. This is the equipment. This is the total bus having navigated to the front of the equipment. This is the view in Gazebo and in a robot visualizer. This is the view that we have. And for this is the view that we have. So this is what the robot sees under the total bus camera view. This is what the robot sees at the point when it navigates to the front of the camera, and it takes a picture of this in order to be able to say, okay, in order to be able to estimate the reading of the gauge. So for data collection and processing, this is just a bigger image to show what exactly is happening. The robot navigates to the front of the equipment. It takes a picture, as you can see, the robot camera. Then this is the view in Hafiz, like what the robot is seeing using camera and depth camera and point cloud image. This is what the robot is seeing. It takes a picture. Then here, like I was saying, it crops out. It autonomously crops out. We wrote some simple algorithm that crops out the area of the image, and for it to navigate, for it to calculate the pressure reading. Then at the end of the day, this is what it does. It calculates the pressure reading based on the dial gauge, and the angle. We've been able to calculate the angles based on the readings. We created like a range for the pressure based on the dial reading, just like you have in a normal dial gauge system. And at the end of the day, it calculates the pressure as this for one of the scenarios. We actually repeated this a couple of times, and the result was same. So for the contribution of this study, yes, it's a first step into some of the autonomous means of performing some routine operator tasks in nuclear power plants and power plants in general. It can be used in maybe like water plants, pressure plants, ammonia plants where you have like ammonia and dangerous gases, where you have to have people go back and forth to actually look at what's happening in that one. So basically, the contribution of this study is that it's a way of autonomously monitoring industrial equipment. Then for the impact, this can help to improve operations and maintenance activities rather than plan on humans, which sometimes might not show up, or maybe things might happen or whatever. The reliability of using a robot to do this is actually promising. Then in terms of cost saving, you don't have to employ so many personnel to actually routinely, maybe every hour, to go over there. One robot can actually do the work of like maybe 5 to 7 persons you might want to use routinely in a day. It also eliminates the risk of hazardous situations. And sometimes we also know when speaking to the power plant people, we also notice that sometimes you might need to shut down the equipment to actually carry out some tests or to actually take some of these readings. This can be eliminated using a robot. Presently, the limitation of the study is that we've not actually tested it in real world and do some extensive validations. This is because it's still an ongoing work. Then also, we are looking also at a way of actually having, when the picture is taken, the algorithm can autonomously detect the area where you have the gauge and crops that out. That would take some machine learning and deep learning processes. Then for future studies, we are looking at dynamic scenarios where it doesn't have to be the position of the robot doesn't have to be hard-coded in then people's reaction to robots, then lack of robot manipulators. That is like, if you are going into the place, the robot has to open the door, or somebody has to open the door for the robot. But with a robot manipulator, the robot can actually do that itself. So thank you for everything. This is questions, and the reference is used for the study.